So in this problem, we're given a hoop of mass m and radius r that is suspended at a nail at the very top of the hoop. We're told that it's displaced some very, very small angle theta, and we're asked to find the period of its subsequent motion. So the only forces on the hoop are gravity and the support force from the nail. And so in order to avoid having to deal with the support force from the nail, we're going to analyze torques about that point. This is also convenient because this is the point that the hoop is rotating around. So this tells us that the torque due to gravity, which is the total torque on the hoop since we're calculating about this reference point, we know that the torque acts at the center of mass. And we know that the hoop is going to be displaced some distance theta. And so if the nail is here, then this tells us that the force of gravity acting at the center of mass we know is r cross f, so that's going to be mg r sine theta. And it's going to be minus mg r sine theta because if theta is rotating in this direction, then torque is going to be pulling it back in the other direction. So we know that theta is very small, so that tells us that sine theta is approximately theta. So then we know that torque is equal to minus mgr theta. Now we also know that torque is equal to I alpha, so now we have to figure out what I is. I, using the parallel axis theorem, since we're not rotating about the center of mass, I is equal to I prime plus md squared. I prime, the moment of inertia about the center of mass, is mr squared since this is a hoop. Md squared, displacing the reference point at distance r, so that's also going to be mr squared. So I is equal to 2mr squared. So this tells us that 2mr squared theta double dot is equal to minus mgr theta. Dividing through and pulling this term over, we get theta double dot is equal to, theta double dot plus g over 2r theta is equal to 0. This is a differential equation for harmonic motion. And so we get that the period is equal to 2 pi times the square root of 2r over g. And so this is going to be the period of the hoop if it's displaced a very small angle theta.